Okay, in the last video, we discussed partial fraction expansions, and I want to continue the discussion with the same example that we were looking at in that video. However, I want to show you how we can solve the problem using the computer software WX Maxima. Now, I've already emailed you uh, where to find it on the web and to download it. It's free. Now, it may not be the most uh, sophisticated equation solving software, but it is free and it is very powerful. So that's the one that I'm choosing to use here for us in this course. Now, here's the problem that we were looking at in the last example. It was this function f of s, which is a polynomial, although obviously a simple polynomial, s plus 3, divided by another polynomial. This is s cubed plus 7s squared plus 10s. So just in case it's a little bit unclear, these are s's, okay, s, 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 s here too. Okay, now in order to do the partial fraction expansion, well, what we first do is we factor the denominator. And in this case, the denominator factors as shown here, s times s plus 2 times s plus 5. Now the partial fraction expansion is taking this whole thing right here for f of s and writing it like is shown right here, okay, where we have a1 divided by s plus a2 divided by s plus 2 plus a3 divided by s plus 5. So we factor it and get the factors. Then using those factors, we can rewrite the expression like this. And I said that this is extremely useful in science and engineering when we're trying to solve differential equations. This is why we do the partial fraction expansions. And so this is why we're learning how to do this. Now we went through the exercise, which I'm not going to repeat here at this moment, of how to find these coefficients a1, a2, and a3. And we found that a1 was 3 over 10, a2 was negative 1 over 6, and a3 was negative 2 over 15. Okay, now what I want to do now is show you how we can use the software WX Maxima to do this partial fraction expansion and get the solution to the problem. So here I have the WX Maxima window open. Okay, so what I want to do first is I want to actually input what the function f of s is. So I do that right here. Okay, I say it's equal to s plus 3 divided by, now let's move over here so I can see what I'm doing, divided by s cubed plus 7 times s squared, 7 times s squared. Now remember to put the asterisk in there as the time sign. If you don't put that in there, you'll get an error when you try to run the program. So 7 times s squared plus 10s. Okay, so that's our function f of s. Okay, now what I'm going to do is I'm going to go up to my um, menu, and I'm going to go under the Calculus tab and come down to where it says Partial Fractions. And now it asks me a question. It says, okay, is this the expression I want to do the partial fraction of? And it has a variable n. I don't want variable n. I want my variable to be s. So I want to do the partial fraction expansion of s plus 3 divided by s cubed plus 7s squared plus 10s. That looks right. So let me hit OK. OK. Incomplete number, missing exponent. Looks like I have some kind of an error here. I don't know what that error is. Let me try this. Copy. calculus, partial fraction, s plus 3 divided by s cubed plus 7s squared plus 10s. S, okay. I still get the same thing. Let me try changing the variable to x and see if that helps. X shouldn't make any difference. Here's it. Should have had 10 times s right here. Okay, 10 times s. So that was the mistake. It was what I just told you to watch out for. So let me change that to x since I've changed everything else to x. I forgot that. Now do calculus, partial fraction, variable is now x instead of, okay, there we go. Okay, so we have a1, we have, it's got the coefficient of the x plus 5 term is negative 2 over 15. Okay, so that's what I'm calling a3. So negative 2 over 15. The coefficient of the 1 over x plus 2 term, right here, the a2 is negative 1 over 6. And then we have 3 over 10, okay, over the x term. So this is the solution using our Maxima software, WX Maxima. So as long as you don't make mistakes typing things in, it is really a pretty powerful piece of software. Okay, so we'll be going through some more examples of partial fraction expansions and of methods of using the WX Maxima, which I hope that we all become proficient in as we're moving along. Okay, until next time.